Okay, let's talk about the test. I have some data to look at. So this might be difficult to see, but let's look at this one first. Well, I guess we can look at this one first. So this is the distribution of A's, B's, C's, D's, and F's. So you can see we had 9 A's, 7 B's, 4 C's, no D's, 2 F's. And then the grades, if you wanted to see what they were for the class, let me just get this out of here. You can see this is each student's grades. So we had 2 100s, 99, 98, you can kind of see here. And then the 2 F's here at the back. Now, as far as the class average was an 84.3.2. Okay. And there's another number here, 12.17. This is called the standard deviation. Have y'all ever heard of that before? Anyone know what standard deviation is? Who's heard of that? Someone said they did, no? You heard it? You have an idea of what it is? Yeah. Sorry, I'm not trying to put you on the spot. Just so look. What's that? Yeah. We all understand what an average is, right? You just take all the scores, add them up, divide by how many students there were. This grade, or this number is important to me, but actually this one is more important to me. I know for you, you want a high grade, but for me, I look at this number. So let me explain what this is. So let's just say I had 2 students, that's it, just 2 students in the class. And let's say that one of them got 100 on the test and my other student got a 0. What would the average be? 50. It would be a 50, right? Add them up, divide by 2. So you'd have an average of a 50. This would be your average. Okay, but if I had 2 students, one of them got a 75 and the other one got a 25, there what would the average be? 50. Still 50, right? And then imagine I had 2 students and they both got 50s. What would the average be? 50 still, right? So even though the average tells you something, I'm more interested in knowing how far apart my students were. So like here, average of 50, but one student knew everything, the other student knew nothing, right? Here they were a little close together, and here they were about this, well, they were the same, right? So when it comes to the standard deviation, in this case you would have a very large standard deviation, and here you would have a very small standard deviation. So what I'm looking for here is a small number. And small for us means anything lower than 15 is small, all right? Most classes are about 18 to 19 is what I see here. So this is an extremely small standard deviation for a class, which is good because that means that everyone's kind of together as opposed to I've got half this class understands it, the other half doesn't. Does that make sense? So overall, I'm very pleased. I think the exam was pretty straightforward. It was just like the review. So if you could handle the review, you could handle the exam, right? Okay, so any questions before we move on? Sure. Okay. So we don't do like makeups or, you know, redos or anything like that in this class. We just keep going, right? But that's one exam out of what, 4 or 5 that we have in here? All right, so we need to get back to where we were. We were talking about percents, right? Percents and proportions. This is where we were. Let me find my erasing rag. Y'all doing all right? Why are y'all so quiet? What's going on? Are y'all tired? It's 11 o'clock, right? Are y'all all right? Nervous. Why are you nervous? Okay, do we need to go out and run some laps around the building or something? Y'all all right? Let's open a window. How about we do that? We'll let a little bit of light in, natural light in here. Ooh. Is that all right? Okay, so we talked about already how you take a statement like this and convert it into an equation. And on the test, I asked you to do that, right? We didn't do a lot of word problems. We did a few, right? Yes? Mm-hmm. Okay, so, and this is actually the homework, so I need to scroll up a little bit and get to the, yeah, okay, so we did I think this one right here with the transfer students to UTSA. So now what we're going to do is we're going to talk about proportions, right? Proportions and percentages. And when it comes to proportions and percentages, they are very similar, but there's also a difference. So let's see. Does anyone have any food with them, like a bag of chips or a candy bar or something? Water? No, not water, because water has 0 calories. Something else that has some. No one has anything? You have gum? Okay, so look. I want you to look on the back of that. No, just look on the back, and I want you to tell me how many calories are in one piece of gum. 5 calories?
Yes.
Okay, so for this particular gum, all right, we have that 1 stick of gum, right, is equal to 5 calories. Do y'all know what a calorie is? Y'all know what calories are?
Like a unit of energy?
It is a unit of energy. It's actually, and when we talk about energy, the standard way to look at energy is actually heat. So a calorie is the amount of heat required to heat up 1 cubic centimeter of water by 1 degree. So imagine you have a little cube of water, okay? It's 1 centimeter by 1 centimeter by 1 centimeter. And let's say it has a certain temperature. If you put a little candle underneath that, the amount of heat required to raise the temperature of that little cube of water by 1 degree is 1 calorie, all right? Now, when we look at calories here, like on your gum, I believe, if I'm not mistaken, that they're talking about, that's actually kilocalories, so it's actually 1,000 calories. It doesn't, don't worry about it. It says 1 calorie. 1 calorie is what we read off the back, but it's 1,000 of these boxes, if I'm not mistaken. All right, so I just want you to know that it's a measurement of energy, measurement of heat. So if you eat 1 stick of gum, it's 5 calories. If you want to burn that off, if you want to make it where that never happened, you never ate that, right? Then you need to move your body and generate enough heat from your own body to raise the temperature of water by 1 degree. That's why when you run and sweat and you get hot, that's your burning calories, right? Okay, proportion. So when we're talking about proportions, this right here is a proportion, right? That is a proportion. So when we look at proportions, I want us to look at this from 2 different perspectives. If I take this equation, if I divide both sides by 5 calories, just agree with me or disagree with me, this is what I would get. So I divide the left side. I divide this side by 5 calories. I'm just going to put CAL. And I divide this side by 5 calories. What would happen here if I divide this side by 5 calories? What would I get? 1. Okay. All right. So do you agree with that? Okay. What if I did it the other way? What if I divide both sides by 1 stick? Then what would I get over here if I divide this by 1 stick? 1. And that would be equal to 5 calories over 1 stick. Okay? You with me? Now, both of these proportions are called proportions. This right here, right, and this right here are equivalent because they're both equal to 1, right? Okay, so how are we going to use this? What's the point of this? All right, what are we doing? All right, so let me get you to a problem now. So I would like to know how many calories are in 5.75 sticks of gum. Now, I realize you could probably do this just by saying, okay, each stick is 5 calories, right? So I'm just going to multiply this times 5. Does that make sense that you would do that? Okay, but that's not the way I want you to do it, because what I'm trying to do is set you up for a method that we're going to use to convert like miles per hour over to inches per second. All right, these are called dimensional analysis problems, and this will come up, especially those of you going on and doing anything medically related or chemistry. This definitely will come into play. So when you have a problem like this, the way I want you to visualize this is you're going to write down what you're given, 5.75 sticks of gum, right? And then what we're going to do is we're going to create a fraction out of this. So we're going to take this and divide it by 1, because that is the same thing, isn't it? Right? Okay. Now, this is how many sticks of gum we have. What are we asked to find in the problem? How many calories, right? So somehow I have to convert sticks over to calories. Agreed? So I want you to look over here at both of these equivalent proportions, and I want you to tell me which one of these has calories in the numerator, in the top. This one right here, right? So what I'm going to do is I'm going to take this and multiply it by 1. And we know that when we multiply something by 1, it doesn't change, right? But the one that I'm going to multiply it by is this. Okay, I'm going to write 5 calories on top over, what, 1 stick? Like that? Now, what happens when you have something in the numerator and something in the denominator? You can cancel them out, right? These will reduce and be gone. Do you all agree? And what you're left with is just calories. And you have 2 fractions you're going to multiply. So when we multiply fractions, we just go straight across, don't we? So at the end of the day, you are going to do this number times this number, right? But do you see how I set it up? I think it'll be useful as we move on if you can understand this. All right, so let's multiply. Someone with their calculator do that. What is that? Calories. Someone?
28.75.
28.75. There we go. That's how many calories. All right? So this was a very basic problem just to get us started. The idea is this. If you start with some given information, some equivalent relationship, you can always create 2 separate proportions out of that equivalence. Then, if you're presented with a problem and you're trying to get from something to the other thing, like from here, sticks to calories, you will choose one of those, which will make the calories appear here and the other one cancel. All right? So we're going to do another problem. It'll be something different, but it's going to be the same sort of setup. All right, let's look at number 11. Make that a little bigger so we can read it. Nope. Maybe we should put some music on in the background or something. Y'all are so quiet, it's bothering me. All right, a leaking pipe can lose 24.7 gallons of water per week. How many gallons are lost in 30 days? All right, understand? Okay, so we have this pipe. This particular pipe is losing 24.7 gallons every week, and we are going to try and figure out how many gallons we lose in 30 days. All right, so the first thing I'm going to do is write down what's given to me, and that is that 24.7 gallons is how much water I will lose in 1 week. Right. Does everyone understand that that's my original equivalence that's given to me? 1 week will be equal to 24.7 gallons of water lost. Agreed? Mm-hmm. So from that I can create 2 proportions. One of them looks like this, 24.7. I'm just going to go with G instead of writing gallons over and over. And then I'm going to put 1 week here. Right? Or what's the other way I could write this? 1 week over 24.7 gallons. So those are my two proportions that I can work with in this problem. Now, we're asked how many gallons are lost in 30 days, right? So I'm going to start now the problem by writing out 30 days over what? 1. Actually, I'm going to need a little more room, so I'm going to do it down here. 30 days over 1. And now at the end of it all, I need to be, my final answer needs to be in what? Gallons, right? So I've got to somehow turn this 30 days into gallons. So what's the first thing we can do? Can we use one of these? Can we use one of these that will basically have the effect of canceling my days out, right? So I want my days to cancel and I want gallons to appear. Does that make sense? Yeah. But do you see we have a problem? Mm-hmm. What's the problem?
We have to convert the days to
We got to get days to weeks first, right? If we're going to use one of these, then we need to convert our days to weeks. So this is where you have to come up with your own proportion using what you know about days and weeks. And we know that what? 1 week is 7 days. So that allows me to create two proportions, doesn't it? 1 week over 7 days. Or I could use 7 days over 1 week. And again, you may be sitting there like going, look, I really could have gotten this answer already if you just let me do it my own way. But trust me, as the problems get harder, you want a systematic way of going through it. You really do. And this is when you, no one here has to take chemistry? No? Yeah, chemistry? You will need to take it? You're taking, so you'll do dimensional analysis, which is basically this, and they have all these units and things have to cancel. And this is basically the same idea, all right? All right, so let's first try and get our days over to weeks. So which of these two will I use right here? Because I'm going to multiply by something. I want the days to cancel. So over here, the left one or the right one? The left, because the days are on the bottom, right? So I'm going to put days down here. 7 days is 1 week. And see, the days there will reduce out or cancel out, right? So now I've got things to weeks. Now I want my weeks to cancel. And I want gallons to appear, don't I? So left or right here? Left one, right? The weeks are on the bottom, so that would cancel down, and I'd be left with the gallons on top. So I'm going to multiply this up here by 24.7 gallons, and down here 1 week. And there goes the weeks. So do you see that all we're going to wind up doing here at the end? Where's my calculator? There we go. All we're going to do here at the end to multiply this out is to do this number times that, times that number. So multiply all those together. You don't really need the 1 there. So I would get 741 gallons, but what is on the bottom still? 7, right? Just 7. Right? That's 1 times 7 times 1, so you just get 7. So I need to figure out what that is. So I will have lost 105.8, let's say 6 gallons. Right? So if you have a particular pipe that's losing 24.7 gallons in a week, then in 30 days you will have lost 105.86 gallons. Yes?
Like, can we do this like much easier by just converting the week into days?
You could have just done 7 days here. Yes, 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 yes. That's what I'm saying. Later on, we might be doing something like, this might be something equals 1 inch, right? But then we need to convert it to meters. So you aren't going to be able to switch that inches to meters right here. You're going to need something else here to go from the inches to meters. So I'm just trying to give you a procedure that's going to work. I mean, yeah, you could have just done this is 7 days, that equals 7 days, and we would have been done. But you see what I'm trying to give you something more constructive for further down the road. On a test, I don't care. If you wanted to do that on a test, make that 7 days, then go for it. All right, we good? Let's look at another one. Maybe one more. And we're going to get more practice with these once we get into conversions, but this will at least get us set up. So see if you can get this one going. All right? I'm going to let you read the problem, see if you can set up your conversion factors, and then come up with the multiplication. So Joe's heart beats 11 times in 10 seconds. At that rate, how many times does his heart beat in 60 seconds? This one's a little more straightforward than the last one. So I have my little sticks. I'm going to be calling on people here today. Anissa is up. I'm going to ask the questions though. All right, so what was the equivalence relationship that you can start with here? 11 beats equals 10 seconds. Okay, from that, did you set up two different proportions? What's the first one that you did? 11 beats over 10 seconds. And the other one?
10 seconds over 11.
So we can use either one of these? Okay, good. All right. Gabriella? Where's Gabriella? Gabriella, did you do something like that? Okay, so have you gotten to the next part? Okay, so what did you write down next?
60 seconds over 1.
60 seconds over 1. And then I'm assuming you multiplied that by one of those, right?
Yes.
And you used which one?
11 beats over 10.
11 beats over 10 seconds. And that's because that will allow your seconds to cancel, right? That's what you want. Cancel, cancel. And then when you go across and multiply and divide, you get 66 at the end, right?
Yes.
66 beats. Again, I think you could have just looked at this problem in the very beginning and given me that answer without actually writing anything down maybe. But again, it's more about the procedure right now than it is about an easier way. Okay? All right. That's it for now for proportions. We will revisit them. We will revisit them in a little bit. We have to go back to percentages for a moment. So when we talk about percentages, there's a formula. There are two formulas that we're going to talk about here today. And they're both useful, I think. The first one, so the formulas that we need for percents. Yeah. The first one is this one. T equals P plus P times R. Now I'll tell you what each thing here is. T is equal to the total cost. P is equal to the price, and R is equal to your tax rate. And as a decimal. All right, so we all know that when you buy something, most of the time you have to pay tax on it, right? Not everything is taxed. What's not taxed? Water? Yeah. I mean, certain food is not taxed, right? Gas is not taxed. Well, it's included in the cost per gallon. I mean, there is a tax. You're definitely paying tax within the price of gas. It's just not tacked on to the end. All right, so let's say you go to buy a computer, right? You say, okay, it's time. I need a new laptop. You go and let's say you have that the laptop is, I don't know how much you want to spend on a laptop. $13.50, right? So you have this laptop you want to get, right? And you want to know how much you're going to wind up paying for it at the end. What will the total cost be for you? Well, the total cost will be this formula, which is the price, which is this, plus the price times the tax rate. Now, the tax rate depends on where you live. So here in San Antonio, what's our tax rate? Do y'all know what our tax rate is here? 8 point something. Is it 8.25? I don't pay attention to it. I don't think I have a receipt with me anywhere, but let's just go with 8.25%. Right? So the question here is, what's the total cost going to be? Find total cost. All right, so let's just put our formula down here. T equals P plus P times R. And so our total will be our price, which was $13.50, plus our price again, $13.50, times the tax rate. But the tax rate in the formula must be written as a decimal. So you have to convert this over to 0.0825. So remember, we're going to move that 2 places to the left. So when we multiply here, I'm going to multiply it times 0.0825 and then put it all together. So you could probably do this on your calculator all at one time. And let's just do that real quick. So you're walking out the door 1461.375. Oh, sorry, can't go that far, right? These are pennies, so we'll just round it to 3/8. So this laptop that's listed online on the ticket there in front of the laptop says $1,350. When you're all said and done, this is how much you're going to pay. All right? Okay, so let's do a different problem, all right? Let's go out to dinner with some friends of ours and let's pick up the tab and let's see how much it's going to cost us. So you go out to dinner. You get, see, everyone eats really, really good, all right? So let's say you have a lot of friends and you feel good that day, you're gonna buy it for everyone. All right, so the amount of food off the menu, okay, when we were looking at the menu prices, was this, all right? So how much are you gonna pay at the end of the day, all right? So what should we also consider at this point? The tip? We are going to tip, right? Are we going to tip?
You have to.
You don't have
You
to.
have to when you have more than like 10 people.
Oh, this is only like five of your friends. You're drinking very hard, okay? And you're ordering everything you wanted, all right? So But we are going to tip, right? Because we're not like that, right? So what are we tipping? What's the standard tip rate nowadays?
15%.
15?
Yeah.
Really?
Yeah.
I think it's like 12%.
12? No, it's not. It hasn't been 12% ever. I don't think.
Night, then 50%, but usually
I think
it's
this depends on who you ask, right? If you've ever waited tables, it's definitely 20.
It has the percentage thing right there.
Yeah. So let's see. Let's go with 20. All right. I think 50. Does that seem unreasonable? 18? 18?
15.
15? I think 15 is like the bare minimum, right? Anything under 15 I think is an insult. Really, I mean, I used to wait tables, that's how I got through college, and like 15% was like the minimum that you would expect. Why are y'all freaking out? I don't make it up, this is our society, right? How much do waiters make per hour?
Like 2 cents per dollar.
It's not much. I don't know, I don't remember because those checks never mattered to me. The tips are what mattered. So waiters don't make good hourly rates. They live off their tips. Okay. So that's like $2 or $3 an hour. That's it, right? So they don't make minimum wage plus tips. The tips are included in that estimate of how much they make an hour. So, okay, so we're gonna tip 18%. All right. A lot of times on the bottom of your receipts when you go to eat, all right, a lot of times it'll have all your information here. At the bottom it'll say like 15%, 18%, 20%. I've never seen higher than 20%. And it'll tell you what your tip should be. Like that way you don't have to calculate anymore. Have you ever noticed that? Okay. I was actually at a restaurant, a local restaurant recently within the last few months, and these were actually incorrect. Like these numbers were wrong. They were lower than what they should have been. And so I was telling my waiter, I'm like, you realize that y'all are all getting tipped incorrectly off of this if people are looking at this. Like, I don't know, there's a problem. There's a glitch in the system. The computer was off. So this was really like 11%. This one was really like 14%. So anyway, but I told the manager I don't think anything is ever going to happen with that. But okay, so how much are we going to pay? Well, what's the first thing we have to do? Tax, okay, so we have to pay tax on this food, right? So my question is this. Are you taxed, you're taxed just on the food, right? You're not taxed on your own tip, right? Like the tip is not included. So let's figure out how much we're gonna pay in tax first, all right? So how much are we gonna pay in tax? So what would our total be if all we did was not tipped? So that would be how much the price is plus the price times the rate, right? So our price is $251.35 plus $251.35 times what? Well, what's our tax rate? 0.825. So we're going to, let's stick with the same tax rate. All right. So 8.25. Sorry, I have to convert that to a decimal, don't I? 0.0825. All right, so let's do that. Someone on their calculator, well, hold on, let me call on someone. Is Timothy here?
Yeah.
Yep, and you happen to have a calculator in your hand. Awesome. All right, so what did you get? Did you do all that? Go ahead, take your time.
Got 272.086.
Wait, hold on, 272.086, so let's say 09. Yeah? Okay, does anyone else have that same answer? Just, we want to double check Timothy there. Yep. Not that we don't trust you, but we just don't trust you. Yes?
So
You got
I tried
it?
to do that on my calculator.
Yep.
And I like, even for the previous.
Did you type it all in at one time?
No.
You did.
I'm adding those two and then I multiplied.
Ah, okay, so remember order of operations. Addition comes after multiplication. This is multiplication, right? So you have to do this first.
Those two.
These two multiplied, then add that,
Okay.
right?
Yeah.
Or on your calculator, you could type that in plus that times this, and your calculator will do the correct order of
So you
operations.
gotta do the order of operations.
Yep. All right, so this is how much we're going to pay. If we were going to stiff the waiter, okay, give them nothing, this is what we would be paying, right? But we're going to pay an 18% tip. So now there's another question. And that is,
Before taxes.
what are we tipping on? Are we tipping on the before taxes amount, or are we tipping on the after taxes amount?
It has to be after tax.
Does it have, well, does it have to be anything? It doesn't have to be anything, right? Like there's no written rule you have to tip 18% or 15%. It is understood, right? It's understood, and it's what's the word I'm looking
Can I
for?
make more money on
What's the word I'm looking for? If you're one of those people who go out to dinner and don't tip, then that's, I don't want to say unethical, but what is it? What is it? Cheap? Okay, whatever, however you want to look at it. But there's no written rule that says you tip on this or this. There's nothing written down that says which one you tip on. I think the standard practice is to tip off of this. That's the standard. Like if you were to ask a waiter, most of them would say, yeah, you tip off, like that's what you're supposed to. But they hope you tip off of this because they'll make more money this way. So I always tip off of this. And that's only because I used to be a waiter. And I always do 20% no matter what. So this is the number that we're going to tip off of. All right?
Okay.
So we need to now figure out what our total is going to be. So how can we do that?
We change the 18% to decimal,
Change the 18% to a decimal, and then do what?
multiply,
Times this?
and
And what's that going to give us?
That's going to give us the amount we subtract from.
Add to the total. Add to the total. You're going to subtract?
No, I meant add, sorry.
Man, I don't want to wait on you. All right, so we are going to figure out what the tip is. We're going to first take this amount and multiply it times 0.18. So our tip will be equal to 272.09 times 0.18. So this is now like a new tax rate, but it's actually a tip. And Elizabeth has that for us. Where's Elizabeth?
me.
Oh, you have that for us, right?
That's 48,
What? 48?
48.97.
97, let's just go with 9.
90.
Yeah, let's just go with that. That's good enough. That's a good enough tip, I think, anyway. Okay, so that's how much we're tipping, right? Yeah? And now what is our total going to be? Final total.
2106.
Yeah, we're going to add those two together, right? So what is it? 321 point.
Oh, wait.
Wait, hold on. Oh, wait, I wrote that down wrong. Sorry. I trust your answer. Say it again.
2106.
321.06. Okay. There you go. So when I was a waiter, we had this thing when you were looking at what restaurant should you go work at, right? We had this thing called a PPA. Anyone know what that stands for? Not many waiters in here, huh? Per person average. So let's say you go out to eat tonight at Chili's, right? Like even if you're really hungry, like what is the most you're gonna spend? Look at the whole menu, look at the entrees, like what's the most you're gonna spend, right? And on average, what is the per person average at a restaurant like Chili's? So what would you say? If you had to pick a number, like think of like Chili's or something like that, how much do you think the average person spends there?
$30.
$30? Does that seem reasonable? Give or take? Give or take 30, maybe 15, depends, right? Well, I would say maybe you could say somewhere between 15, 30, I don't know, 25, whatever, right? But somewhere in there, right? Okay, have y'all heard of Morton's Steakhouse? Okay. A single steak is like 50, 60 bucks, and then you have to order all your sides separately. So your per person average at a place like Morton's is going to be way higher, probably over $100 a person. So if you're working at a restaurant, right, and your customers are paying $30 on average versus someone who's working at Morton's, that waiter's $100, then they're going to make more, right? off of each customer because they have higher bills. And the rate does not say, oh, but if you're at Morton's it's less, or if you're at Chili's it's more. This is 18% no matter what, or 15%, however you want to look at it. So you would think this would be better, right? The only difference, I think, is that at Chili's you're gonna go through more people. You're gonna have a lot more customers. You know, turn and burn them, just get them in, get them out, get them in, get them out, get them in. Yeah. Here, there's a quality of service, and the people that are going to eat at Morton's are going to stay there for a while. They're going to make an evening out of it. They're going to spend several hours at Morton's, so they don't turn as many people over. Does that make sense? So yes, they will make more, but they don't have as many people. So you want to try, if you're going to wait tables, to work at a restaurant where you have a pretty high PPA, but you're also able to turn through the tables. I don't know why I'm talking about it. I'm not trying to encourage you to become a waiter or anything. I'm just... All right. Let's look at another problem here. Hey, when you buy a car, do you pay tax? Yeah. Let's say you have a car right now that you own. You own it. You have that car, right? It was given to you by your grandma or something like that. You got this car. You take it in and you trade it in. Do you pay tax on that new car? Yes, you do. You pay tax on the difference. So like if let's say that you have a car that's worth $5,000. That's what you've got, a car worth $5,000. You don't owe any money on this. And you go in and, well, actually, even if you do owe money on this, if it's worth $5,000 and let's say you go buy a car that's $25,000, you're only going to pay tax on $20,000. So whatever you trade, the difference is what you pay tax on. And the tax rate for cars is lower than like for food. It's like 6% or something like that. But we're going to talk more about that later when we get to like finance stuff. We can talk about that at the end of more towards the end of the semester. All right, let's do something else. I'm trying to make these problems like relate to the real world a little bit for you. I want to do a problem, yeah, here we go. Let's do a problem where we have a discount. So you plan to buy a TV, which is $499 right now. You have a 20% off, I don't know, coupon or something. What is your total? All right, so the first thing we have to do here is figure out the cost of the TV before tax. So this is kind of interesting. I'm curious to see what people will do here. So I'm just going to call on someone here. Nivini? If I told you that a TV costs $499, but you have a 20% off coupon, how would you determine how much that TV is going to cost you? No tax. Don't worry about the tax yet. Okay, that's fine. What if it was a $100 TV and it was 50% off, right? Then it's okay in your mind that would mean like half, right? So here, 20% off is a little different. We're not quite taking 50% off. We're trying to take 20% off of this, right? So how could we do that?
You can multiply by 0.80.
Ah, okay, so you beat me to it. There's two ways to do this. There's kind of a short way and a fast way. If you take $499 and you want to take 20% off, then what you could do is you can multiply it by 0.2. That's 20%, right? Okay, let's do that on our calculator. Let's see what we get. Where did I put it? Oh, it's right here. There we go. This would be 99.80. So this $99, that's not the cost of the TV now, right? This is 20% of it. So you would now need to take that off of that total, right? So if I did that, I did 499, I subtract 99.80, you get 399.20. So that's how much the TV would cost you at 20% off, right? So to do it this way, we had to multiply by how much is off, get that total and subtract it from the original, right? The faster way is to do this. 499 and then multiply that times 0.8. So where's the 0.8 coming from? Yeah, you're saying, look, if you're taking off 20%, then really you're paying 80%. And if you multiply those, what do you get? This right here, right? I prefer this way. If you want to know how much you're going to pay for something that has a discount, just multiply it times 1 minus the discount, if that makes sense.
50%, I just go around.
Multiply times 0.85.
Okay.
Yeah.
Yeah, like that.
Right? See how that's a lot faster?
Yeah.
Okay. So let's use this method to finish this problem out. We plan on buying a TV. It's $499. We got a 20% off coupon. That's going to take our price to this. Now we need the total, so we need to include tax, right? And the tax rate, we're just going to stick with the same tax rate that we've been working with. So our total will be P plus PR, which our total is our price was $399.20 plus $399.20 times our tax rate, and our tax rate is 0.0825. And we'll just do that all in the calculator at one time. And let's see, Dyson here? You got a calculator or no?
Yeah.
Yep. Did you get this yet, or we got it? What do you got?
I got $432.
15? Okay, thank you. What?
13.
13 cents, okay. And did you have to round this? No? It was like 1.3 exactly?
134.
134. So you rounded it down, right? Have you all seen that movie Office Space? Right? So like you said, you rounded this down and it was actually 0.4 something. That movie Office Space, you know, they run this scam, and what they're doing is they're saying, look, you know, a bank, when they compute things, they always have to either round up or down, right? So that part that's left over, they were putting that into an account. Right? So like if I round this down, there's still like 4 thousandths of a penny. There's 4 thousandths of a penny that got kind of vanished, right? Because we rounded. They put that into an account and they thought, oh, we'll get a little extra money that way. And it turned out that it got them, like, I forget how much it was, but it was like thousands, hundreds of thousands. I don't remember. Anyone remember from the movie?
Millions.
It was millions or something. And they're like, oh, shit. They didn't realize it was going to do that. So they had to, blow up the whole place, or someone blew up the whole place? They burnt it down. So anyways, our banks, our financial institutions, they have to round, right? So there is this weird kind of what happens to that, right? It's not going in your pocket, I can tell you that. All right, so there we go. So this TV that was $499, 20% off. After tax, you're walking out the door $432.13. I always look at it like whenever I have a 10% off something, I always just think to myself, well, that's pretty much going to kill the tax, right? Because tax is about 8%, 10% off, you're going to kill the tax. So if something's like $4.99 with 10% off, I feel like I'm going to pay about $4.99. It's going to be close to $4.99, right? Y'all doing all right? Okay, let's talk about percent increase and percent decrease. This is a different formula. So here's your second formula. Percent increase or decrease. All right, so the way this formula works is that you have the new the new amount minus the old amount, and you divide that by the old amount. And that's your formula for determining a percent increase or decrease. So let's use as an example gas prices, all right? So let's say that yesterday you drove by and you saw that the gas prices were, I don't know what they are right now today. Did anyone get gas today? No? Yeah, we'll go with yesterday. They were $2.24 a gallon, all right? And today, the gas prices are $2.20 a gallon. I would like to know what the percent increase or decrease was for this. So would this be an increase or decrease? It's going to be a decrease because the price went down, right? So which of these two is the old and which one is the new? Yesterday is the old, today is the new, right? So we just plug it into this formula. We take the new amount, which is $2.20. We subtract the old amount, which was $2.24, and we divide that by the old amount. And you always divide by the old amount. And let's see what Jameson. Where's Jameson?
Right here.
Right there. Oh, you don't have a calculator, right? No? Okay, don't worry about it. Don't worry about it. How about Danny?
I got 1.8%.
1.8%. So what did you get as a decimal over here?
0.0178.
Did you get a positive or a negative? You got a negative, right? So you got negative 0.0170,
70.
something like that. Okay, so when you do this on your calculator, be careful because you have to make sure that you do this before you divide by this. All right? Did anyone else get this answer? Yes? All right. What I'm getting at is if you try and type this all in at one time, you can get it wrong. Let me show you what I mean. If I type 2.2 minus 2.24 divide by 2.24, if I do it that way, I get 1.2. That is incorrect. All right? Because what your calculator does, if you type that in, 2.20 minus 2.24 divided by 2.24, then your calculator is going to do this first, right? Because division comes before subtraction. And when it does 2.24, when it divides 2.24 by 2.24, it gets 1 here. And then 2.2 divided by, or minus 1 would give you 1.2. But that is incorrect, because this is the real fraction. You have to do all of that first, then divide by this. Okay, now as a percentage, this is 1.7%. Now what about the negative? That tells us it was a decrease. So we're going to ignore this, but here we need to put decrease. If this was positive, then it would be an increase. So the change in gas price from yesterday to today, there was a 1.7% decrease. Yes?
Is it still a negative even if it's a percent?
Yes. Well, the negative is what tells us whether or not we're having increase or decrease. Okay? So the decrease is coming from that negative, but when we write the answer, we'll just leave it as a positive percentage. But we need the word decrease with it. All right. How are we doing on time here? 11:55? Got a little ways to go before we take our break. Okay, now we are done with this section, but I'm looking at some of the problems in this section, and this one right here causes all sorts of trouble for students, which I completely understand. Yeah, there we go. Okay, so let's take a look at this one. So right now we are basically looking at a problem where this could have to do with percentages or proportions. all right? To estimate the number of trout in Bear Lake, a sample of 48 trout were captured and tagged. After releasing them, they were released, a net captured 300 trout, 9 of which were tagged. What would be a good estimate for the number of trout in Bear Lake? And this is actually how they estimate populations of fish and wildlife. They catch a group, they tag all of them, they let them go, and they come back a few months later and they catch another group and they say, oh, how many of those had tags in them, all right? So it's kind of like if I were to capture all of you, right, and then tag half of you, right, and then go out later on and take another random sample of people, and I should expect that half of them are tagged or no? No? Let me draw a picture. This might help. Let's just say that this is our lake, okay? And inside this lake, there are all these fish in here. Those are my fish. Pretty impressive. All right, so you got all these fish in here. If we catch a sample, right, so we take a sample of this. So we capture them, right, here they are. And we tag them, so let's put them in red because they're tagged. And then throw them back in there. What's our picture going to look like now? We have a mix, right? We have the ones that are there along with the ones that have been mixed in with them, right? So now if we go back and we capture another sample, sample 2, this will be sample 1, then we're probably going to have some of the blue and some of the red in this sample. So think about this. What if you capture a sample and there are no red ones in here? What would that tell you about this population? Is it big or small? It's big because you captured some, threw them back in there, then when you took another sample, none of them were in there. So that gives you an idea that that's a pretty big population, right? Because the number of tagged ones that were in there, you didn't get any. What if you captured and you saw a bunch of the red ones in there, right? Then that should tell you that, look, that's a pretty small population because when I captured this second sample, a lot of the original ones that I captured were still there. Does that kind of make sense visually? Now, when we do it with a proportion, I think it will hopefully make a little more sense. Okay, so here we go. Let's use the numbers here. We have a couple of things in this problem that we can label. How many tagged fish, tagged from the sample did we have?
9.
From the first sample, sorry. Okay, so we captured the fish, we tagged 48 of them, right? We'll call this sample 1, all right? We tagged 48 fish. Now, what about our total population? Total population. Do we know that? Do we know our total population? We do not, right? We don't know the total population. What about our second sample? What was our sample 2 population? What was the population of our second sample? 300 fish, right? And how many were tagged in the sample 2? There were 9. Right? All right, so what I'd like to do is try and set up a proportion. Can anybody from this information give me a proportion I can set up or an equivalence? You know how we